Hey everyone, and welcome to today's Explainer. I'm so glad you're here, because we are diving right into a truly fascinating medical journey. We're going to be exploring the management of adult-onset diabetes, which you probably know as type 2 diabetes. But more specifically, we're tracing the pretty remarkable evolution of the exact medicine that makes managing this condition possible. We are looking at the evolution of insulin, tracking its history straight from the early days of animal extraction all the way to the absolute marvels of modern genetic modification.
But, before we get deep into the weeds of the history, let's just ask a super practical question. Honestly, it's probably crossed your mind if you or anyone you know is managing this condition. Why can't we just take insulin as a pill? I mean, we take literally everything else orally, right? So, why is this specific medication so different? It's kind of the perfect puzzle to kick things off.
All right, let's jump straight into part one, the basics of insulin.
So at its core, insulin is what we call a hypoglycemic hormone. Basically, that just means its main job is to lower your blood sugar. And naturally, your body produces this using these specialized little things called beta cells, which are located right inside your pancreas.
Now, this specific hormone is really the star of our explainer today because it's the absolute #1 key to managing adult onset or type 2 diabetes. When the body's natural system struggles to keep up, we have to step in and supply this crucial hormone ourselves.
Which brings us to section 2, the delivery problem.
Okay, so here's the catch. Insulin is a protein, and if you swallow an insulin pill, your stomach acid acts just like it would with any other protein you eat. It literally digests it completely before it even has a chance to reach your bloodstream. Poof, gone. Because of that, we desperately need a delivery solution that bypasses digestion entirely. You just can't give it orally. So, the medical field has to rely on insulin injections just to get the hormones safely into the body where it can actually do its job.
And that takes us to part 3, the animal extraction era.
So looking back at the timeline, early on, insulin actually had to be extracted directly from slaughtered cattle and pigs. Sounds a little crazy now, right? And it was a logistical nightmare. But more importantly, it introduced a huge medical complication, severe allergic responses. Let's look at exactly why that happened.
Well, because this hormone was sourced from animals, the human immune system would look at it and say, nope, doesn't belong here, and frequently reject it. This caused some really dangerous allergic reactions for the patients who were just trying to get their life-saving medicine.
Which leads us to the big breakthrough in section 4, the genetically modified solution.
This whole situation perfectly illustrates such a massive medical leap forward. We moved from this really precarious era of relying on cattle and pigs and, dealing with those awful allergies to the absolute marvel of modern genetic modification. Scientists were actually able to engineer insulin that completely bypasses those animal-induced allergies. It provided a safe, entirely scalable solution, a total game changer.
And looking back over the original source notes for this topic, you can really trace that entire evolution. It perfectly maps the whole journey, right? Starting from the pancreas, hitting that major roadblock with digestion, pushing past the messy animal extraction era, and finally reaching the triumphant creation of genetically modified insulin.
So, as we wrap up today's explainer, I want to leave you with something to chew on. Knowing exactly how genetic modification completely solved this insulin allergy crisis and totally transformed how we manage type 2 diabetes, what other older medical treatments do you think science is going to revolutionize next? We just saw how a massive physiological hurdle was bypassed by pure, unadulterated scientific innovation. It definitely makes you wonder what the next big breakthrough is going to look like, doesn't it? Thank you so much for hanging out with me for this explainer. And hey, stay curious out there.